Now we've seen that that second criteria for a PDF is really important because often we need to restrict the domain or those bounds so that the area underneath a curve does qualify as being a PDF by equaling 1. Now, what do we do if there are no upper or lower bounds? Can a curve stretch on to infinity or negative infinity and still qualify as a PDF? Well, yes, it can, as long as it meets that second criteria. So the only issue really is that we're going to have bounds that might be negative infinity or infinity. And when we go to sub those in, we of course can't do that. So rather than subbing them in to solve for our PDF, we need to just take the limit as x approaches infinity or negative infinity and do some reasoning. So an example here, we need to show that y equals 1 over x squared, where x is greater than or equal to 1, is a PDF. Now, how do we do that? Well, we need to basically show that if we take the integral from 1 up to infinity of this curve, it needs to equal 1. Okay, well, I'm going to rewrite this from the start here, only because I don't have very much board space. Let's rewrite this as x to the power of minus 2, because that's going to make it much easier to integrate. Now, it's a show that question, so I've redefined my show that question here so that I can really see what it is that I'm trying to show. So that's step 1, I think. Step 2, I'm going to say that the left-hand side is equal to, now I can use my square brackets here, I need to integrate this. So that means I need to actually raise the power by 1, so it's going to be x to the power of minus 1. And then my method is I think about differentiating that. The negative 1 will come down. There isn't one there already, so I'll need to put 1. And then this will drop to a minus 2. So yes, I can verify that when I differentiate that, I'm going to get that. Then I need to put in my bounds. All right, next step, I sub those bounds in, or I take the limit as x approaches those bounds. Now I'm going to start by just subbing the bounds in so you can see what you get here. If we've got minus x to the power of minus 1, don't forget that's the same thing as this. And if that's a little bit easier for you at this stage, feel free to change your notation so that it looks like that. I'm going to continue on over here. All right, now that is equal to negative 1 over infinity minus negative 1 over 1. Now, negative 1 over infinity is the part that we can't do, but we can reason that if you've got 1 over infinity, you've got a number that is as good as 0. Now, if it's negative 0 or positive 0, it doesn't really matter. This is effectively 0. And now here we are subtracting negative 1, which means that we are adding 1. And so we can see that sure enough, we get 1, which is equal to the right-hand side. So this part here was the only part that was a little bit tricky. We just needed to consider what happens when we have a fraction with a huge number on the bottom.